Hi guys, good evening. How are you all doing? Let us start today's session on the steel structures. So whoever are watching, let me just know in the comment section if I am audible so that we can proceed with this session. So today what are we doing? We are solving the test solutions of design of tension and compression members majorly. Okay, so this test was conducted yesterday on the Ekeeda app. So before getting into this, I would like to tell you for the people who are new, you can download the Ekeeda app from the Play Store or from the link which is in your description box or the live chat box. Okay, so we have academic courses, competitive exam courses, professional courses, all recorded subject wise courses will be there, branch wise courses will be there, which you can take up accordingly for whatever you need, right? And whatever doubts you have, you can come to us in the YouTube live doubt solving sessions and get your doubts clarified. And every Sunday we have tests that have been conducted in the app. We also provide with the notes, test series and all. Also, we give you certain internship assistance and job assistance. So for more details, what can you do? You can just download the app and go through. And if you're new, you can use the code gold 11 so that you will get complete 3 days free access for all the courses in the app, be it professional or academic or your competitive exam courses. So you'll get a complete 3 days access. So you can use this code. And if you have any queries, you can contact us on 9029006464. Okay. So as I told you, today we are doing the fourth class on the steel structures, wherein we are doing the test solutions for the design of tension and compression members. And also, if time permits, we'll also cover the test solutions of this particular topic. That's important aspects of design of flexural members, plate girders, gantry girders, and industrial buildings. Okay, so first of all, this compression and tension test we will start with and then go on for the next topic depending upon how much time we have. Okay, so let us get started. So this test was conducted yesterday on the Ekeeda app. So every week you will be given tasks to complete certain topics, and once the topics are completed, you will be provided with test series to know how much you have prepared. And after solving, you will have doubt, right? So whether your test answers are correct or what you have scored, and if there is any mistakes, that we will be clearing in the live section like this. What we have. So this test was conducted for 20 marks. There were 10 questions which are of 1 mark each, and 5 questions which are of 2 marks each. Okay, so combined questions for both tension and compression members. So what is tension members? The members which are subjected to tensile forces, you can call them as tension members, and the members which are subjected to compressive forces, you can call them as compressive members. Okay, so like this, right? So for if you want the entire detailed course, you can go to the app and check there. Okay, so today we will do this test solution. So let us start with the first question. For the people who know the answer, you can just type in the live chat so that I can see your answers and then I can comment on that. Okay, if you don't know, it's okay, you can just listen to me so that you get your doubts clarified. Okay, so the first question, beginning with 1 mark questions. So the first question is, consider the following statement for tension members. So they have given certain statements. Okay, 3 statements they have given. So we have to consider these 3 statements. Which of the above statement is or are correct, he is asking you. Okay, so only 1 is the option, 2 only is the option, 3 only is the option, and 1, 2, 3, all the above are the options. So let us start studying one by one. First thing. So in a double angle tension member with the angles on opposite sides of the plate, gusset plate, the net area provided will be same as for the double angle on the same side of the gusset plate. So if you have a plate like this, and if you say have a angle section like this, okay, say you have screwed it here and you have screwed it here. So what is he telling? The net area provided opposite. So when you provide like this, the net area of the gusset plate, so I'll call it as A net, this will be equal to, say I have two angles at this on the same side. Say this is a front view. Okay, so if you see in the side view, if say this is your plate, you will get one angle section here and one angle section here on the same side of the plate, not on this side. On the same side of the plate you have been provided with two angles. So even in that case, the bolts you have or the connections you have will be two. So this net area, is this net area equal to this net area? So when angle is provided on both opposite sides and when angle is provided on the same side, is the net area same? He is telling it is same. So this option is perfectly correct. Okay. So this option is perfectly correct because angles are two, bolts are two, whether it is on same side or on different side, it is doesn't matter. So the first statement is correct. Moving on to the second statement. A tension splice member is designed for maximum of compressive or tensile force in the member. Okay, so this is absolutely wrong. So what is the exact correct thing? So the tension member splice is designed for maximum of factored tensile force, factored tensile force, or 0.3 times the design strength of the member. So whenever you are designing a tension member slice, this is according to your IS 800 2007. So you are designing it for what? Not maximum tension or compressive force in the member, but for the factor tensile force or 0.3 times the design strength of the member, whichever is more. Whichever is more, for that you will be designing. Okay, whichever is more. Okay, so second statement is absolutely wrong. Moving on to the third statement. If a lug angle is required for making connection in an angle section tension member, the effective area of the member will be the gross area minus the area of bolt hole, is what he is telling. So he is telling area effective, let me write it in the terms of formula. So area effective is nothing but gross area minus area of bolt. Is this correct? He is asking. Actually, this is not correct. So the correct answer is whatever is the total area, that should be taken as the effective area. So the effective area should be equal to the area of whole member. You should not subtract the bolt area. Okay, so area of the whole member, or you can call it as just the gross area, or you can call it as the whole area, total area. Okay, so whatever in whichever format you would like, you can call it. Is it clear? Total area. Understood? So this option is also wrong. So the correct solution or the answer for this particular question is what? Only one. That is option A is correct. All other options are wrong. Understood? So this is your 1 mark question. So you should know the standards. Only when you know the standards, you will be able to answer such type of questions. Okay. So moving on to the second question. What does it say? For a single unequal angle preferred for making connection is the. So suppose you have a single unequal angle. So like this, say one angle is long and one angle is short like this. Okay. So this is what? Short side of the angle section, and this is the longer side of the angle section. So this is what your angle section. So which side do you use for connection is what he is asking. Okay, so the option says, so this, let us call this question number 2. We'll just name the questions so that by the end we'll come to know how many questions we have solved. Okay. So the options what he is giving are the longer one, shorter one, any of the two, longer if bolted and shorter if welded. Okay. So in this particular case, the correct answer is the longer one. Okay, so basically whenever we are doing the connection, whether say it is bolted, riveted or welded, when you are connecting a angle section to any of your plate, say your gazette plate only, so you have to connect the longer side. Okay, so the longer side is better or preferred over the shorter side. Why? Because when we use the longer side and keep the shorter side like this freely suspended, we can reduce the shear lag which is happening. Okay, so in order to reduce the shear lag which is happening, we can go for the connection of the longer one. Okay, so it's an important question which you should be knowing. Understood? So the correct answer for this is what? Option A, that is the longer one. So in case of unequal angle, the preferred side for making the connection is the longer side. Okay, many of the times this type of question has been asked. Okay, so I believe I'm audible, right? Okay, chalo then. So let's move to the next question. What does it say? Third question, question number 3. The strength of a column depends on which of the following imperfections. Okay, so there's a column. Okay, whatever may be the end conditions of the column, don't bother about the end conditions. So what is he telling? The strength of this column. Columns are normally what members? Compression members, right? So he's asking the strength of the column depends upon which of the following imperfections. So let us read the options. So before reading the options, let me tell you, this is a MSQ question. So for the people who are writing GATE, I hope you all know what is a MSQ question. It is nothing but multiple select question. So what exactly is a multiple select question? See, for multiple select question, there will be no negative marking. Okay, so there will be no negative marking for multiple select question. So compulsory you have to attend this. There's no harm in attending. Okay, but the thing is, it may have how many answers? It may have one answer correct, or one option might be correct. Two options might be correct, right? Three options might be correct, or all four might be correct. So if you exactly give the correct number of answers, only then you will get marks. Say for example, for just for example, I will tell you, say there are out of four options, okay, say three options are correct for a particular question. Okay, three options are correct. So if you choose only two out of these three, you will not get marks. You have to choose all the three. Only then you will get your marks. Okay. So this is all about the multiple select question for the people who don't know. So this type of multiple select question have been started only since past 2 years in the GATE exams. So if you observe from the last year and this year, I mean like if you observe the question paper of 2021 and 2022. In 2021, there were less number of MCQs, whereas in 2022, the number of MSQs have been increased to a very huge extent. So this time also you are expected to, I mean, like you are known to expect more number of multiple select questions. Okay. So in this particular case, I have already told, and in the exam, it will be mentioned whether it is a MCQ question, MSQ question or a NAT question. MCQ is what? You all know what is MCQ question, right? So MCQ question means there will be four options. Only one will be correct. Only one will be correct. So in gate examination, if you attempt the correct answer, you will get 1 mark, right? If you attempt a wrong MCQ question, then the negative marking is minus half. Right, one not minus half, minus 1 by 3. Okay, so that's 0.33 marks of your value will be negative marking. That is your multiple choice question. Then it comes your multiple select question, and the third type of question is your NAT question. What is NAT question? Numerical answer type. Numerical answer type of question. In this, again, there's no negative marking in case of numerical answer type, so you can give the answer without any problem. But the thing is, this is like a fill in the blank. Okay, so this is like a fill in the blank. Normally numerical answers will be there in this. They will ask you exactly for how many decimal places you want the answer, or whether you want it in the form of an integer. So accordingly you have to give. In the answer script, there will be a range given for the correction. So within that range, if your answer lie, you will get complete marks. If not, you will get the 0 marks for that particular question. So these are the three types of questions which you get in your gate exam. Okay, for all the new attendees, this is an important thing to understand. So that's the reason I just gave you an information on this. Okay, so let's get into the question. The strength of the column depends on which of the following imperfection? The first one is geometric variation of column. The second one is eccentricity of load. Third one is shape of error section. And the last one is the material being isotropic and homogeneous. Okay, so he is asking about the imperfection. What is he asking about? Imperfection. So it will, the strength will depend upon the this is imperfection, no? Geometric variation of column, this is an imperfection. Eccentricity of loading, normally we try to take it at the line of action of the load center. Okay, so but there is an eccentricity in the loading. Then shape of error sections, so this is also an option. Only correct thing is the material being isotropic and homogeneous. So for this particular question, the correct answer is what? Option A, option B, option C. That is, on all these three imperfections, the strength of the column will depend upon. What are the imperfections? Geometric variation of column, eccentricity of loading, and the shape of the error sections. Okay, I hope it is clear. Done. Let's go on to the next question. So what is this? Oh, okay, this is question number 4. So this is what? An NAT type of question, numerical answer type. So we have to give the solution in the form of a numerical answer. Okay, let us first find out or understand what the question has for us. Okay, what will be the non-dimensional effective slenderness ratio? Okay, so what do he want? He want to calculate the non-dimensional effective slenderness ratio. So how much is this? This is equal to lambda, which is given by under root Fy by FCC. Okay. Now in this particular case, your FCC is nothing but pi square E by KL by R minimum whole square. Okay. Now let us see what all values are given to us. Now in this also K is nothing but 0.65 L. Okay. Chalo, what all things are given? Slenderness for a column of height height 4 meters, which is fixed at both the ends. Because it is fixed at both the ends, my value is pi square EI by KL by R minimum whole square. Okay. Now in this case, the height is given as 4 meters. Height is nothing but the length of the column you can consider. Okay, capital L. So what will be K? 0.65 of capital L, that is 4, which is equal to 2.6 meter. Then R minimum is given in the question. Assume R minimum as 54 mm. Right. Be careful with the calculation. Okay. They have given us to use the Fe415 steel. So for Fe410 steel, your Fy will be equal to 250 Newton per mm square. Understood? So now you do the calculation. K is known for us. So let us substitute in here. First, let us calculate FCC pi square E. So because he is telling steel, the value of E will be what? It is understood because in is mentioning it as steel. E is equal to 2 into 10 raised to 5 Newton per mm square. So 2 into 10 raised to 5 whole divided by K is 0.65 into 4 KL. Okay, did a small error. Here, this is directly your KL. Okay, uh, let me do like this. So KL is equal to 0.65 into 4. So that's nothing but 2.6. So let me here also write directly 2.6 into 10 power 3. Why? Because this is in meter. I want to convert it into mm because I'm putting everything in mm. Okay. So this is also 54 whole square. Done. So this value, how much will this come up to? 851.47 Newton per mm square. Now, in that case, what will be lambda? I'm writing the lambda value here. Fy, that is 250 divided by 85147. So this will give an value equal to 0.542. Okay, so lambda is equal to 0.542. So in this question, they've not mentioned up to how many decimal place you want to write. So whatever you have got, please write that particular value. But in the exam, it will be mentioned exactly for 3 decimal place, exactly for 2 decimal places. Suppose he asks exactly for 3 decimal place, you write it as 0.42. Suppose he ask you the same question for 2 decimal place, then you have to round it. If you see the third value is less than 5, that is 2, right? So the answer would be 0.54. If he ask exactly for 1 decimal place, see the second value. The second value is again less than 5. So this will be 0.5. Okay. So like this you will have to give the answer exactly up to the decimal place. So if you see the solution key, in the solution key, you know what? The range of the answer they have given is 0.5202 to 0.570. So within this range, if you give any answer, the answer would be correct. Okay. So this is the range they have given in the question solution key. This you will not be seen. The green one you will not be seeing in your question paper. Just to understand how the answer key will be set, I have given you that particular value in the green. Okay. So this is your fourth question. I hope it is clear. Now let us move on to the fifth question. Question number 5. So what does it say? The square root of the ratio of moment of inertia. So what is it? Square root. Let me write the square root. What is here? Moment of inertia. Okay, moment of inertia by the cross section Moment of inertia of the cross section to its cross sectional area. Cross sectional area is called as, okay, so this is nothing but your radius of gyration. Okay, so the ratio of moment of inertia, let me write it in the form of notation, then you'll remember it. So I by A. So generally we take the least moment of inertia to get the least radius of gyration. Okay, just to understand, I told you this. So the ratio of moment of inertia to the uh, area under root is nothing but what? Is nothing but your radius of gyration. Okay. What is second moment of inertia? Second moment of inertia is nothing but the moment of inertia, right? I. What is section modulus? Section modulus is nothing but Z, which is nothing but I by Y max. Slenderness ratio L. What is the slenderness ratio L? So length to least lateral dimension. That will be your slenderness ratio. So for all these options, it is wrong. So the correct answer is the radius of gyration. Okay. I hope it's clear. Shall we go on? Move ahead to the next question. So question number 5. Okay. See, this is a direct question. Standard you should be knowing. Okay. So what does it say? What is the maximum slenderness ratio of lace bars in built up section? Suppose you go for lace bars in built up section, the slenderness ratio maximum should be equal to how much? 145. So this is a standard value. So this is what type of question? NAT type of question. Okay, done. Moving on to the next question. So this is question number 7. Read it carefully. Try to write down what all is given so that you can calculate exactly what you need. Okay. A fillet weld joint is shown in the figure. So this particular weld is a fillet weld type of joint. Okay. Now the size of the weld is 8 mm. So what he has given? The size of weld is how much? 8 mm, and the safe stress in the weld is equal to 110 Newton per mm square. Safe stress is equal to how much? 110 Newton per mm square. What is the safe force in kilonewton to the nearest magnitude? So what does he want? He wants you the safe force. Safe force is equal to question mark, and he want it to be written in kilonewton to the nearest magnitude to which the weld can be subjected. Now we all know what is the general formula for stress. Stress is equal to force by area. See, this is a very basic kind of question. Only thing is the new terminology used here is in terms of your steel structure. Okay. So what is it? Stress is equal to force by area, right? I want force now. So what will it be? Stress into area. So here I'll call this as safe force, right? I'll call this as safe stress into the area of weld. Okay. So let me write F is equal to 100. Right. Now it's very important for you to calculate the area of the weld. So how will you start calculating? First of all, try find the throat thickness. Throat throat thickness is always 0.7 times the size of weld. Okay, this is a standard according to your IS 800 2007. Okay, so this will be what? 0.7 into the size of the weld is 8, which is nothing but 5.6 mm. So at every place the thickness is 5.6 mm throat thickness. Now the weld is for how much area? The weld is for 80 plus 60 plus again this one is also how much? 80 mm. Right. So 80 plus 60 plus 80. So this will be equal to how much? 16, 220. Right. Correct. So this will be 220 mm. Now multiply this. What will happen? So this 220 into 5.6 will be the area of the weld. Clear? I hope you understood how did we get it, right? So on calculation, how much will you get this value to be equal to? 135,520. This is in Newton. Why Newton? This is in Newton per mm square and this area is in mm square and this will cancel. So you're getting your answer in Newton. But you want your safe force to be written in what unit? You want it in kilo Newton. So basically divide this by how much? 1000. You will get it in kilo Newton. So if you divide it by 1000, 135.52 kilo Newton. Right, he is telling you to round it off to the nearest magnitude. So the answer you have to give is equal to 13. So it is not told you decimal. So this is 0.52 greater than zero point 0.5, no? So round it off to the next decimal. 136 kilonewton would be the correct answer for this NAT question. So the only thing what you have to know is on how to calculate the weld area, and that too important one is what? Finding the throat thickness. This is a standard value. If you forget this 0.7 of size of weld, you will not be able to do it. Is it clear? Okay. So I hope it's clear for everyone, right? I don't see any chats in the comment section. Everyone is audible. You're all there. Yes. Okay, chalo. So let's get going further. So this was question number 7, right? So let us move on to question number 8. Okay, now what does the question number 8 has to tell us? Have a look onto the question. So this is the question number 8. So what is it? An equal angle of area A. So there's an equal angle section. So this is your angle section. So the area, the total area of this angle section say is A. Has been welded on one side of the gadget plate. So there's a plate here, right? I've done a weld to this particular angle section on one side. Okay, this is your what? Weld, and carries tension along the axis. So this is carrying what? Tension along the axis. What is he asking you? What is the effective area of the angle is what he is asking you. Say, now this is a single angle, right? This is what? Single angle. Right, I want to calculate what? The effective area of the angle section. So the effective area, or I can call it as the net area, is equal to A1 plus K times of A2. Now, what is A1 and A2, ma'am? If you ask me, A1 is nothing but the area of connected leg. Okay, so this leg area is A1 and the one which is not connected, that is your A2. But we cannot just add it like that. A2 should be multiplied by a constant K and then we have to add it. This is a very important uh, thing to be noted. Okay, so area of unconnected leg, right? So again, so this actually is a by 2. This also is a by 2. But the value of k is very, very important to solve this question. Okay, so I'm writing it as important. Right, so what will be K? The K is equal to 3A1 by 3A1 plus A2. Okay, so 3 times of A1 is A by 2. A1 is A by 2. Again A2 is A by 2. So on simplifying, what will you get? 3A by 2. And here let us take 2 as LCM. So this will be 3A plus A. So this will be 3A by 2 whole divided by 4A by 2. This and this cancel, this and this cancel. This you will have a value equal to 3 by 4. So how much is K? K is equal to 3 divided by 4. Right? Now calculate the A net. You get your solution. A net is equal to A by 2 plus 3 by 4 of A by 2. So in this case it will be A by 2 plus 3A by 8. So for 8 and 2, so for 8 and 2 the LCM will be what? 2 2s are 1, 2 2s are 1. Okay, 2 2s are 4. Right, 8 will be the LCM. Actually you don't have to calculate. It's okay. So 8 will be the LCM. So this will be multiplied by what? This will be multiplied by 4 and this will be multiplied by 1. So you will get 4A plus 3A. That's nothing but 7A by 8. So either you write it as 7A by 8. See, this is again a NAT type of question. Okay, so you have to give it in proper decimal. So 7 by 8 will give you a value of equal to 0.875A. Okay, so 0.875A is what is the effective area of a equal angle section. Because he's told equal angle, what did I do? A1 and A2 I took as A by 2, A by 2. Okay, that is very, very important. Also, the value of K is very, very important to solve this particular type of question. So let me write it as answer. Clear? I hope it's clear, right? Now moving on to the question number 9. So what do we have in question number 9? The maximum center to center distance in mm between bolts in a steel member of thickness 10 mm will be. Now check, very very important question. Okay, now again let me tell you, this is a MSQ question. So multiple select. There are more than one correct answer. Okay, now what are the options? 16 mm when member is in tension, 120 mm when member is in tension, 160 mm when member is in compression, and 120 mm when member is in compression. Okay, so first of all, the thickness of the member T is given as how much? 10 mm. Now, here the distance between center of two adjacent bolts. So let me write it for you. Whatever is there in your IS 800 2007. So the distance between centers of two adjacent bolts in a line lying in the direction of stress shall not exceed 16T or 200 mm, whichever is less in tension Wait for it. Let me first write down the clause, whatever is there as it is. Then I will explain you. It will be easy for you to understand. Okay. Whichever is less, or 12T or 200 mm. Again, whichever is less in compression. Okay. Now, first let us do it for tension. So what we have to do, we have to choose even for tension, we have to choose even for compression. Okay. For tension, we have to give this whichever is less, and for compression we have to give this whichever is less. Now the T given for us here in this question is 10 mm. So either 16 of 10 or 200 mm. So 16 of 10 will be 160 or 200 mm. So whichever is less. So the correct answer will be what? For tension, 160 mm is the correct answer. So 160 mm when the member is in tension, this is a correct answer, right? And also for compression we have to do it differently. So 120, 12 of 10, 12 of 10 or 200 mm, whichever is less. So 120 or 200 mm. So what is it? 120 mm when it is in compression. So this is also a correct answer. So here in this option he has just interchanged the tension and compression just for you to be confused. So the correct answer for this is what? Option A, comma D. Both are correct answers. You cannot just write one and leave one. If you do like that, you will not be fetching full marks for this. Is it clear? Chalo, next question. So this is the last question for 1 mark. Then we'll get into the 2 marks question. So the 10th question. What does it say? For a steel built up column. So what is it telling? For a steel built up column subjected to an axial force. So the force given to you in the question is how much? 2150 kilo Newton. Okay. So the lace system is to be designed for resisting a transverse shear of. So it's asking you to calculate the transverse shear in case of lacing system. Okay. So if you go for lacing system, your transverse shear is equal to 25% of your axial force. Very simple. This is a standard which you have to remember. Right. So what is it? 25% is nothing but 25 by 100 into how much is the axial force? 2150. So on calculation, how much will you get? 0.25 into 2150 you do. You will get the value equal to 53.75 kilonewton. Do we have an option? Yes. 53.75 kilonewton is the correct answer for this particular question. Is it clear? Now, let us get into the 2 marker questions. So, the first question in the 2 marks section, question number 1 in the 2 marks. What will be the tensile strength due to rupture of critical section of an angle section? So, there is an angle section ISA 150 into 15 into 8 as shown in this particular figure. So, always you remember whether it's a welded connection, bolted connection or any type of connection for unequal angle, what we do for unequal angle, we try to connect the longer leg, right, when compared to your shorter leg to your gazette plate. Okay, the dimensions are given. So they have you asked us to use Fe 410 grade of steel. right? So for Fe 410 grade of steel, your ultimate stress is nothing but 410 Newton per mm square, and your yield stress is 250 Newton per mm square. This is a standard. They will not tell you every time. If it is given Fe 410 grade steel, this has to be considered. Okay. Then what is he asking you to calculate? The tensile strength due to rupture of the critical section. So he's asking you to calculate the TDU. Okay, so the tensile strength due to the rupture of the critical section. So you have a standard formula. Let us first write the formula so that we will come to know what all elements have to be calculated in order to substitute in the formula. Okay, so what is it? This is equal to 0.9 ANC Fu by gamma m1 plus beta Ag naught Fu whole divided by gamma m naught. Now, what is the length of the outstanding leg? So let me write all the values. Okay, length of outstanding leg is nothing but the leg which is not connected. Okay, so this is equal to 115 mm. Let me call it as W. So what will be the weld length along the direction of leg? Weld length along the direction of leg. Now the leg is like this, right? So the weld length will be the length of this particular longer leg. So LC, I'll call it as, it is 150 mm. Now what is the weld of the width of the shear leg? Width of shear leg. Generally the leg which is not connected is called as the shear leg. So the width of the shear leg, I will call it as how much is it? 115 mm. Right. Now, why am I doing all this? Because I have to calculate the value of beta. So how will you get beta is, beta is given by the formula 1.4 minus standard, it is 0.076 by W by T into Fy by Fu into Bs by Lc less than or equal to 0.9 Fu gamma mo by Fy gamma m1 greater than or equal to 0. Okay, so try to do the calculation. 1.4 0.076 W is how much? 115 by thickness of the uh, this one weld. So this I'll call it as T. Okay, then Fy is 250 and Fu is 410. We have already seen. What is Bs? Shear leg length, that is nothing but 115, and the total weld length is nothing but 150. Right, we are getting this equal to 0.08893. First I try to calculate this value. Now I'll try to calculate this value. Okay, so let me do one thing, change the color and do it so that will be easy for you to understand. Right, so 0.9 Fu is 410, MO naught is 1.1 and M1 is equal to 1.25 for welded connection. Okay, so keep this as a standard, you should remember it. So it's 1.1 whole divided by 250 into 1.25. So this is coming equal to 1.29888. Now obviously, so this is actually greater than or equal to 1 minute. This is not 0, 0.7. Right. So this is greater than 0.7. So what will happen? Beta is equal to what? 0.8893 is less than 1.29888 and is greater than 0.7. So beta should be chosen as what? 0.8893. So in this particular formula, the value of beta is 0.8893. Now what else I have to calculate? I have to calculate the NC and GO, gross and the net area, right? So let me do the calculation. So NC is what? The area of connected leg, area of connected leg. So how much will this be? This will be equal to 150 minus 8 by 2, that is 150 minus 2 times the thickness by 2 into 8. So 1168 mm square, and the area GO is nothing but the area of the outstanding leg, area of outstanding leg is equal to what? 150. No, not 150, 115 it is, right? Arey Baba, where did it go? Right. So 115 minus 8 by 2 into the thickness. So how much will you get? 888 mm square. So finally your TDN will be equal to, let me do all the substitution, 0.9 into ANC. ANC is nothing but 1168 into FU is nothing but 410 divided by gamma M1, that's nothing but 1.25 plus beta 0.8893 into the area AGO, that's 888 into the FY, that is nothing but 250 whole divided by gamma MO, that's nothing but M 1.1. So this answer you'll be getting in Newton. So how much is it? It will be 344.79 plus 1179.48 kilonewton. Kilonewton, I've converted it to kilonewton. Just have a look at it. So this will be 524.27 kilonewton. Right, this will be your correct answer. So in the question they will ask you whether he wants it in kilonewton, newton or whatever, that will be mentioned in the exam. Also the rounding off to which decimal also will be mentioned to you. Okay. So what is it? The tensile strength due to rupture of critical section. So TDN answer is 524.27 kilo Newton. Is it clear? I hope you have understood this particular question. Alright, now let us, so this is the first question from your 2 marks questions. Let us move on to the second question. What will be the, so this is your second question. What will be the block shear strength of a tension member as shown in the figure? So what is the tension? So it's asking you what? The block shear strength of the tension member. So how do you call, what is the notation for the block shear strength? TDB1. Okay. So again we have a standard formula, AVG. See, in steel structures, if you don't know the standards, you will not be able to do any of the problem. So basically steel structures is entirely code based, standard based. Okay, you have to be very careful. So if you know the formula, is just direct substitution with the standard values. Okay, so your block shear strength of a tension member is given by this formula, which is AVG-FY by root 3 gamma m naught plus 0.5 ATN FU by gamma m1. Now let me see all the calculations. Be careful with the calculations. Okay. Now first thing what you have to calculate is what? See, generally this is also called as what is this? Oh, let me tell you. So this is your shear yield and tension fracture. Similarly, you also have to calculate T dB2. So this is equal to how much? ATGFY whole divided by gamma m naught plus 0.9 AVN FU by a root of 3 gamma m1. Right. Now what is this? This is nothing but your tension yield. So you have to calculate shear yield as well as tension yield. Okay. So the tension yield, the first one, the shear yield is also no, and here there the tension fracture will be there, and in tension yield you will have shear fracture. Okay. Once you calculate these both, your block shear strength will be the what? Anyone? Should I add it? No. It should be the minimum of TBD1 or TBD2. Understood? You have to take the minimum of the two values. Now let us calculate first one by one. So first I'll calculate all the areas which are required. So gross area in shear AVG. Okay, how will you calculate this? See, gross area in shear will be nothing but the bolt to bolt distance, right, into the thickness. So the bolt to bolt distance will be what? 50 plus 115, just the edge distance and the pitch distance into the thickness. So how much will it be? 1320 mm square. Then along with that, what do you need in this formula? Tn you need in this formula. That is nothing but the net area in tension. Net area in tension. So how much is the net area in tension? See, this particular zone will be in tension. So 35 minus 0.5 times of 18. Okay, so half of the bolt dia. Okay, so this will be the net area in the tension. So which is equal to how much? 208 mm square. Right. So do the substitution. Rest all things you know. They have given you Fe 410. So Fu will be equal to 410 Newton per mm square and Fy will be equal to 250 Newton per mm square. And whether it's for bolted connection, again your gamma m for normal shop weld work, gamma m1 will be 1.25 and gamma m naught will be equal to 1.1. So AVG is 1320, FY is 250 whole divided by root 3 into 1.1 plus 0.9 into ATN is 208 into Fy is 410 whole divided by 1.25. Okay, so how much will this value come up to? So it is 173.21 plus 61.4 kilonewton. I've converted it to, so it will be 234.61. So the shear yield or the tension fracture dB1 is equal to 234.61 Newton. Similarly, I have to calculate what? TDB2, which is nothing but the tension yield or the shear fracture. So now in this I need T area TG is nothing but the gross area in tension. Gross area in tension. How will you calculate that? So the gross area is nothing but 35. Don't take the bolt, don't uh, subtract the bolt half dia. Okay, so that's nothing but 35 into 8, which is equal to 280 mm square, right? And then we need what? The net area in the shear, that's nothing but AVN, net area in shear. So in net area, what I have to do? So in gross area, 115 into 50, I did know, but I have to subtract 1.5 times of 18 because I have to remove one full bolt here and half full bolt here. Right, this into the thickness. So this will give you 1104 mm square. So do the substitution. This will be 280 into 250 whole divided by 101 plus 0.9 into AVN, nothing but 1104 into FU is 410 whole divided by a root 3 into 1.25. So this is giving you a value equal to how much? Let me check the calculation. So you will get it as 63.64 plus 188.16 kilo Newton. So this will be 251.8 kilo Newton. Is nothing but your tension yield or the shear failure. Now what I have to do for finding the block shear strength? The block shear strength is the minimum of, what is the first value we got? We got it as 234.61 kilonewton, or second value we got it as 251.68. So this one is in shear yield, this one is in tension yield. Shear yield, tension yield. So what I have to choose? I have to choose the minimum of the two quantities. So this will be your correct answer. Do I have the option written to me? Yes, it is option number A. So see, in order to confuse the first option, what he gave is the tension yield. You should not take the maximum. You should take the minimum of the two values. Understood? Oh, so, sorry, I guess the mic was on mute. So this is the question number 3. So let me just quickly tell you. Steel plates, each of width 150 mm and thickness 10 mm, relate to their relate to three 20 mm dia rivet placed in a zigzag manner. So there are two plates which are of 150 mm width and the thickness of 10 mm, and there are three rivets like this in zigzag manner. Right, the pitch between the rivet. The pitch is nothing but in the horizontal direction, the distance between the rivet is called as pitch. So that is given as 75 mm. And in vertical direction, the distance between the rivet is called as your gauge, which is given as 60 mm. If the allowable tensile stress, so in the question they have given us the allowable tensile stress. So how much is the allowable tensile stress given to us? 150 megapascal. Then the maximum tensile force that the joint can withstand is, we have to calculate the maximum tensile force. Okay. Now how do you calculate the maximum tensile force? We have to calculate most critical sectional area. So there will be many sectional areas. We have to calculate the most critical one and multiply it with the uh, stress. Okay, so basically your force, your maximum tensile force will be equal to the tensile stress into the most critical area. Okay, now how do you do or go about this problem is, see, they've given us the diameter of rivet, right? Diameter of rivet is given as how much? 20 mm. So what will be the gross diameter of the hole? Gross dia of hole. It cannot exactly be the diameter of the rivet. So we have to just increase it by 1.5. So this is a standard. So there will be 21.5 mm, and pitch is given to us, which is equal to 75 mm, and the gauge is also given to us, which is equal to 60 mm. Now, the most critical sectional area has to be considered. So, the first section I will consider is section 1, 2, 3, right? This section I will consider section 1, 2, 3. Okay. So, in section 1, 2, 3, what will be the net area? The net area will be the thickness into the breadth minus nd, or n times of diameter. So the thickness is given, the thickness of the plate is 10, the breadth total between 1, 2, 3 is 150 minus n. N is the number of rivets coming there, it's only 1, and the diameter, this diameter is nothing but the whole diameter which we have to choose, which is nothing but 21.5. So how much will be your net area? Your net area will be 1285 mm square for the section 1 to 3. Right. Now moving on to the next section. So the next section will be, just see what will be your next section. 4, 5, 6, 7. 4, 5, 2, 6, 7. So this 4, 5, 2, 6, 7 I'll take as the next section. We have to check all the sections and see which will be the most critical one. Okay. So section 4, 5, 2, 6, 7. How will you calculate the net area? Again the plate thickness into the breadth is 150 minus 3 into 12.5, 21.5, because there are 3 rivets which has to be subtracted, right? Plus what we have to do, plus 2 times of pitch square by 4 into 60. That is pitch square by 4 times of gauge. Understood? So this will give you a value equal to 1285 mm square. Then moving on to the next section, the third section. So what is the third section we have? 4, 5, 1, 3. So what will be your net area? So that will be 10 times of, again the width minus 2 times of, because in 4, 5, 1, 3, see where is 4, 5? 4, 5, 1, 3, we are only taking up 2 rivets in 4, 5, 1, 3 area. So this 4, 5, 1, 3 area like this. Okay. So 2 times of the dia. Again, plus 75, there's only one gauge, one pitch and one gauge, which we have to consider. We don't have to multiply this twice. Okay. Now, how much will this area come up to? This area will be equal to 1304.375 mm. Now moving on to the last section, what we have, I'll just erase this so that you can easily understand. So what will be the last section we have to consider? 4, 5, 6, 7. Just this one without consider this rivet. Okay. So that is your section 4, 5, 6, 7. So what will be your net area? 10 into 150 minus 2 times of 21.5. That will be equal to 1070 mm square. Now, whichever area you're getting the least will be the most critical. Okay. So this is 1285, 1285. This is also 1285. This is 1304. Sorry, this is not 1285. Just done calculation error. Okay, I'll just change it for you. So this we are getting as 1323.75. Okay, and 1070. So which is the least one? The least one is nothing but 1070. Right. So now just do what? The maximum tensile force at that joint, right, will be equal to what? 150, which is nothing but the tensile stress given to us in Newton per mm square into the area. The least area or the most critical area is 1070, which is for 4, 5, 6, 7 section. Okay, so that will give you 160.5 kilo Newton. So this will be your answer. So for exact decimal place, if you want to give based on what value they have asked, which decimal they have asked, try to give it in that particular way. Is it clear? Right, next. There are two more questions which we will be solving for today. Okay, now heading into the question number 4. This is a little bit easier question for 2 marks. So a steel column pinned at both ends have a buckling load of. So he's telling that the steel column is pinned at both the ends. Okay, so in that case, what will be the buckling load? The buckling load P1 should will be equal to pi square EI by L effective square. Okay, which is equal to pi square EI by L square, and this value is given as how much? 300 kilo Newton. Right. Now, if the column is restrained against lateral movement and rotation at its mid height, its buckling load will be. So he is telling they have restricted the column's lateral movement and rotation exactly at the mid height. Okay. So in that case, what will happen is your L effective will be 0.7. See, the L effective here he has given to adopt the L effective as 0.707 L for one end fixed and one end hinged. Now because at the center, see, it is he's telling pinned at both ends, no? So initially say there is a pin at both the ends. Now we are restraining at exactly L by 2 for lateral movement and rotation. Right, now the length has become L by 2 and here this has become fixed, this has become hinged and this has become hinged. So now if you consider only this much, what will it be? It will be one end fixed and one end hinged. That is what he has given us, right? But for this, the length is what? L by 2, not L now. This is what is given to you. But according to what we have seen in the question, your L will become L by 2, right? Clear? So this will be equal to how much? 0.3535 L. So how much will this value be equal to? So if you go on calculating, now this be very careful. Now your second case, first case is I have assumed that it to be both ends hinged and I have done this. Now here because we have fixed it at the center, so this will be what pi square EI by L effective now is 0.3535 L whole square. Okay, now on simplification, what will this become? Pi square EI by 0.3535 whole square into L square. Okay, so this entire value, if you observe, this is given to you. How much? 300 kilo Newton, right? So what will be the value? Mm, okay, this if you simplify, you will get it to be equal to 100 by 12.5. Okay, or what you can just directly do it, there's no issue, 300. Okay, or you can write it as 300 whole divided by 0.3535 whole square. So this value will be equal to 2400 kilo Newton. So this is your buckling load. So answer, buckling load when the lateral movement and rotations at the mid height of the column is restricted will be equal to 2400 kilo Newton. Okay, I hope it is clear. Now moving on to the last question of today's session. So that will be your question number 5 of 2 marker for tension and compression members. What will be the value of the non-dimensional effective slenderness ratio for a column which is composed of ISHB 300, okay, so ISHB 300 is given. If the length of the column is 3 meters, though L is given to you as equal to 3 meter and its both ends are pinned. So whenever both ends are pinned, your KL will be equal to L, which is equal to 3 meters, or you can take it in mm, which is nothing but 300 mm. See, all other values are given to you. R minimum or RYY is given. So we need it for our calculation, right? 54.1 mm. And then E is nothing but 2 into 10 power 5 Newton per mm. Sorry, this is square. And Fy is also given to you. Now what do we have to calculate? We have to calculate the value of the non-dimensional effective slenderness ratio. So let me write the formula. So what is the slenderness ratio formula? Non-dimensional effective slenderness ratio is nothing but lambda, which is equal to root of Fy by FCC. Again, FCC we'll have to calculate. Fy is given to you in the question. Now, what is FCC? FCC is nothing but pi square E by KL by R minimum. We have done similar type of problem in the 1 marker question also, right? If you remember. So, it will be pi square E is 2 into 10 power 5 whole divided by L, because it is both ends fixed, it's going to remain KL will be equal to L. So in Or what you can understand is the value of k is equal to 1 if it is both ends pinned. Like that also you can remember. Okay. Then R minimum is 54.1 whole square. So your FCC will be equal to 641.92 Newton per mm square. So how much will be lambda? Lambda will be equal to 250 divided by 641.92. So under root value is lambda will be equal to 0.624. Understood? So that's your non-dimensional effective slenderness ratio. I request all of you to have a look on how to use the virtual calculator for all the students who are going for gate examination, because major of the questions will be of calculations, right? So if you don't know how to use the virtual calculator and you go on using only the regular calculators in your exam, so that's going to be difficult for you. So it's good if you have a complete look on the virtual calculator beforehand. Is it clear? Now, so this was about the today's session on the test solutions for your tension and compression member. So in the next Monday's class, we will have the test solutions for impact aspects of designing. So this will be conducted next Sunday, this test in the Ekeeda app. So for all the people who don't know about the Ekeeda app, please go to the Play Store and download it, or you have the link in the live chat. So if you use Gold 11 code, you'll get a 3 days complete access, free access for all the courses which are there in the app. We have all the recorded courses, professional course, academic course, and competitive exam courses. We also give internship assistance and job assistance to certain level, right? And also we have many plans like your platinum plan, silver plan, gold plan, based on what category you want. If you want individual subject wise also, you can take the subscriptions. Or for any doubts regarding the app or anything, you can call us on 9029006464 or WhatsApp on this number. We'll be ready to assist you. Okay, so I hope today's session was useful. So in the upcoming session will be the last session on the steel structures. Then this will be followed by other subjects. And then in the month of December, we will be coming up with transportation and surveying, right? So the gate exam is very near. So exactly you have another 60 days, 60 to 65 days left for your gate exam if you're a civil engineering background student. So make the proper use of it. Take the subscription as soon as possible and keep your preparation intact. Okay, so any doubts in the steel structures subject, again we can meet us next week, Monday, same time at 5 p.m. To get it cleared. You can come up with your questions. We'll try to help you as much as possible. Okay, so for today, that's it. So have a good week, effective week. Okay, let's meet again soon. Chalo, bye. Take care.